things ACL2 is really good about is because it's been around for so long and it has been used in this area that's not strictly in the middle of computer science or math. As a result, they have spent a lot more time than a lot of the other groups on very good intro level information. Now, it's still written from a very particular perspective, so they're assuming maybe more Lisp than most people would be familiar with. They're still assuming you're more comfortable with possibly logic gates and things like that, some of the things they hand wave about logic, and then they spend a lot of time talking about things about programming that I think a typical programmer was, okay, I got it. You can gloss past this one, maybe don't gloss past the logic parts as much, but that said, I still think it's absolutely accessible to everybody in our group. And so the first one is what they call the flying tour, and so it's like 10 minutes. It's not even really getting into the guts of ACL2 itself. It's just kind of giving you a rough idea of what is ACL2 used for. It's just an introduction to this. We're covering a lot of the same material that's in that one. The ACL2 walking tour is a 1 hour tour, and that one goes a lot more into depth. You actually go and explore an example. We're going to have an example as well, but our example is not going as far into depth as this one does. This one used to be jokingly called the ACL2 crawling tour, but I think they didn't like that name, so it's the introduction to the theorem prover now. This one I've seen people say that it will take you between 10 to 40 hours of work. I think generally people say it will take you multiple days at least to do this one. It could take you a week if you're not like dedicating most of your time to it. This one is once you're done with this, then you're going to be ready to use it for something. Maybe not something brand new, like a brand new area of mathematics or something. That might be a stretch, but if you're using it like as part of your day job at one of these places that's doing ACL2 verification of chips, yeah, going through this will get you pretty far in the direction of what you would need to do that kind of work. As far as actually getting your hands on ACL2, ACL2 has a REPL, which is a great way to get used to it. And you can get the REPL with like apt or Docker or whatever, wherever you've got your different package managers. So you got your read, evaluate, print loop. It's just like the interactive channel, and so then you just type things one at a time. And that seems like, you know, some programming languages lean into that a lot. It is perhaps more obvious why you would want to do that with an interactive theorem prover, because as we said, as you're going through the code, there's a lot of information you need to know about the state. And so you might get some of that kind of information from a programming language. It's a lot more important to get that kind of feedback from a system like this. But of course, Emacs, ACL2 lives in the Lisp world, and as a result, that means that Emacs is very much going to be a thing. And a lot of the people who do the most in-depth ACL2 work use Emacs as their daily driver. And so if you're into that, then it definitely will work. I'm not an Emacs guy myself. I'm much more into VI and try to get back into Emacs so that I can play around with it for ACL2 talk. And no, my hands were like, no, we're not doing that crap. Stop whatever it is you're typing. Like, get back into VI. So, okay, all right. But if you're less, if your hands are more cooperative with typing Emacs commands than mine are, then by all means, that is definitely a supported way of doing it. One interesting area is ACL2 sedan. ACL2S is usually how you'll see it written. It's an extension on top of Eclipse. I can't tell how popular it is out in the world. I kind of get this suspicion that maybe there are specific companies that are doing a lot of ACL2 stuff that lean heavily onto this, and then other people don't use it at all. given that like some of the tools are really, really well defined and documented and everything, and some of the tools in ACL2S seem to be kind of, you know, a half step better than abandonware. So
the last time I used it was with the sedan, and
yeah.
I remember Eclipse being old then.
Yeah. I mean, that's the thing is, Eclipse is its own world. You can get, you know, it's being actively developed, and so if you want like the newest, shiniest version of Eclipse, and then you put this on top, maybe it'll work, maybe it won't work, I don't know. Or you can get like an ancient version of Eclipse, and it'll probably still work. So that is, that's its own thing. I'm guessing from my time trying to get it working, I think it's, you install Eclipse and then ACL2S is like just an add-on. It's not like a pre-bundled setup, which is notable. TLA Plus is another tool that we'll be covering one of these days. And they have gone back and forth with whether they are a plugin you add to Eclipse, or whether, no, we're different enough from Eclipse that we have Eclipse as a subset inside of what we do. And so you sometimes get that. But it looks like, at least with ACL2 Sedan, it seems like it is still operating as a plugin you add to Eclipse. So let's get into some code. A really, really simple example. So if you're not familiar with Lisp, we could talk about, I don't know, how before we get anywhere into there, is there anyone here who feels not comfortable enough with Lisp to know kind of what's happening here? Where we're defining a function, we're calling it max2, it takes two variables, and then the last value inside of this if statement is what gets returned as the result. It's like the return value. So definitely, if there's any questions, if we need to clarify anything about the Lisp code, please raise your hand and we will dig in. I don't want that to be the thing that keeps you from understanding what's going on. So we're defining max2. And max2 is a really simple program. It takes two variables, and if x is bigger than y, it returns x, otherwise it returns y. So in a sense, it's like giving you the max, but maybe equals is in there too, so whatever. So it's like the max function. It is total, which has special implications when it comes to functional programming languages. In a sense, it just means it's a well-behaved program, a well-behaved function. It is recursive. I wouldn't call it recursive, but I guess you can call it recursive. In a sense, that's another one of those.
Use recursive kind of interchangeably with computable, I want to say.
Yeah, in the terms of Lisp, yeah.
Outside of it, programming, say it's recursive, it calls itself.
Usually that's what we do,
like,
but inside of a functional language, sometimes they use these terms to mean slightly different things. It's like in math, you have like open and closed are not opposites, depending on which branch of mathematics you're talking about. They sometimes are, but sometimes they're not. And in this case, total and recursive have special implications to functional programming. But it is executable, so we can say that. So you just type that in to ACL2, and this is what I got. I added new lines here just to make it a little more easy to see what's happening, but normally you just type it in the prompt. So after you type it in, it's spitting out all this other information.
You just told me it was recursive.
Yeah. What's this? It's saying it's non-recursive.
Oh, it's not. Oh, shit. Oops.
Okay. So in programming sense.
Oops.
I feel so much
What definition of recursive are we using on either of these slides?
I think this one is trying to be a little more colloquial, the output of ACL2. So,
Okay.
yeah.
So this one is
The other one, look, I might be wrong on this one also. It's worth remembering. One of the important rules of Charlie is usually wrong. But I remember that total and recursive have different meanings inside of functional programming than you're used to think about. In this case, I think they mean max2 is not recursive in the sense that we as procedural programmers would think of the term recursive.
It does not call itself.
It does not call itself, yeah. So its admission is trivial. So in this case, one of the things that's happening is we've said these interactive theorem provers it's like we're building up things that we know about the system a piece at a time. And so the way that ACL2 handles that is it decides whether whatever you just said is something it will allow it to be true or not. So in a sense, normally with a programming language, you type something in and you're like, all right, done. Now it's true. In this case, no, ACL2 is like, no, that last sentence you just said, not happening. I don't believe it. And it just throws it away. That's just how ACL2 approaches that problem. It just throws things away that it doesn't like. And so in this case, because what you just said is something it's okay with, it's like, oh, okay, I'll admit it. What you have just said, this creating a new function, I will allow you to create this new function. And it notices that the type of max2 is described in a particular way. That gets into this notion of like, you get into type theory and dealing with theorem provers in general. You start to get into things like the Curry-Howard correspondence, where you have this idea that there are relationships between type theory and doing proofs. So their proof theory and type theory are related. And so you can do equivalence between these two systems. And so in a sense, we make heavy use of that knowledge when we're getting into the guts of things dealing with type theory or with proofs, which is why programming language folks and formal methods folks have a lot of overlap. It's because there's a lot of overlap with what they can do with this stuff. In this case, we're playing a little bit fast, not fast, this is accurate, but it's just like, we're saying something about the type of that function in a way that has implications about its computability and things like that.
From what I read of this theorem, from my reading it looks like it's saying just that the output has to be Y or X.
Yeah.
Mm-hmm. Yeah. Yes, well, but it's also important how it's structured this. The particular way that it has structured the output is also has implications about whether or not something else can be proven to be equal to it or not. And so it has to do with how you would calculate the way that it is represented in a canonical form. So anyways, the easy version of this is it admits this to the collection of things which it accepts as being true, and then it gives you a summary of what it did. And so it made proofs that whatever you just said does not violate its notion of the universe. So now we want to prove a property about that max2 function. In this case, it's a really simple one, is that whenever you take max2 of x and y, that the output of that is at least as big as the first input. So it should be pretty easy to see that, convince yourself as a human that must be true. Now, how do we convince ACL2 that is true? Well, in this case, what's kind of interesting, so we're just defining this theorem. So you see it's a slightly different structure. In the previous one, we had it defining a function, max2. In this one, it's defining a theorem. They get into a little more detail inside of the 1 hour tour about it, but this allows you to not specify the specific values that you're passing in, for example. You can say something is true in a general sense. It allows you to make sure that you're not accidentally going to try to, like, give me the max2 at least x of 2 and 3. It's like, well, that doesn't even make sense. Like, this is a property which is true about this thing. It's not something you can go and apply to a specific value. And here's what you get when you type this into ACL2. And so it's giving you some kind of warnings about rewrite rules, which we'll get to that in a minute. But you can see it did something about goal, QED. So QED, that should be a sign that you did something right, or very, very wrong. One of those two things has happened if you see QED show up on the screen. It means we've got a math proof that we have just completed. And it's like, well, we didn't do anything. we just told it, here's the theorem, and then it says like, yeah, cool, QED. And what the answer is it was able to figure out what it needed to do all on its own. So in this case, it told you what it did. It took the definition of max 2, the thing that we had a couple slides before. It took the definition of not, which has a definition of its own that comes built in with the system. And then some stuff about tau. I'm not going to get into that. I don't really know that very well, but yeah, you're getting into the guts here. But the important thing to note is that ACL2 was just able to make the proof all on its own. So you didn't have to like try to tell it how to prove it or something. ACL2 saw like, oh, with what you just said, I'm able to figure out all of that on my own. So in this case, it's just a theorem prover, not an interactive one, because it just did its job and it just told you, yeah, I'm done. So that's cool. So now you can use this statement, this max 2 at least x, in other proofs. And it's also the kind of thing that that ACL2 knows to use in other proofs. Now, we get into the rewrite rule stuff. It's saying that in fact it won't always be used in certain circumstances. We can get into that's a little bit more of an advanced topic in this particular case. But here's where it kind of gets interesting. So sometimes there are other properties we might want to have about a system, which we think are true, but maybe ACL2 will have a little more trouble with. So we want to say that max 2 is commutative. And so that just means that if you get max 2 and you have x and then y, that's the same thing as max 2 with y and x. And so if you think about if you remember back the definition of max 2, that we just take the bigger of whichever of these two. Kind of makes sense. We as people can reason about, like, yeah, this will be true. Like we convince ourselves that this would be true. What's interesting though, is when you actually spit it into ACL2, oh, it gets real upset. This is kind of the tail end. There was a lot more than this. I just had to truncate because it wouldn't fit all on the slide. But here at the end, it's saying that part of what it's upset about is it doesn't know if we can say that if y is less than or equal to x and x is less than or equal to y, that means that x and y are true. Which maybe seems a little bit surprising, since we can certainly convince ourselves that would be true. And so it's like, well, this seems like something that we're convinced is probably true. We don't even know how we would prove it. It just seems so obvious that it is true. How do we even proceed? And that gives you a good indication of some of the kinds of things you'll run into with an interactive theorem prover. It's just because things seem really obvious to you doesn't mean that the way that the interactive theorem prover thinks about these things will be able to figure this kind of stuff out. In this case, I was able to get the proof of max 2 commutative by making these two changes. I introduced a new lemma, which has a cryptic name, but basically is symmetry of greater than or equal to on integers implies equality. And so in this case, I'm saying if I know that x and y are integers, because less than or equal to on their own maybe in some sense could mean something other than integers. Like maybe if you have two lists, maybe one list is less than or equal to a different list. Or maybe you're talking about things that sometimes are less than or equal to something else, but sometimes they are not comparable in that sense. So maybe if you had two lists, one list was a subset of another list, then you would say that that list is less than or equal to the other one. But then if there are two lists which aren't subsets, then it's not true that one is greater than the other one. They're just not, neither one of them is less than or equal to the other one. And so, okay, well, then that would break that notion. But if we say that they're both integers, then we know they're equal. And this one, ACL2 was fine with making that proof. Based off of that,
You just gave it that, what's in this top like 6 lines, and that was enough for it to be convinced?
well, and here's the other trick of this. This rule class is nil. What's weird is this proof is so generalized that if we just left it alone, because back here we said something about rewrite rules. In this case, the rewrite rule that this thing would have generated is so generalized that it would break ACL2 every time it tried to do anything, because it would try this against everything over and over and over again, and ACL2 will just break. And so when you try to run that without the rule class as nil, it'll actually say it won't, it looks like it's saying that this thing isn't true, which was somewhat confusing, but in fact when you actually read the details, it is true. It's not allowing you to say that it's true, because if you said that it was true in a generalized sense, it's going to break the crap out of everything else that happens with ACL2 from then on. And so that's why it's rejecting it.
What is the case with nil where it can't say that it's true?
In this case, it's rule class is nil, so by default, rule classes, there's a whole bunch of different classes. If it applies, if the way you have described this rule can apply to a couple of different types of rules, then it will allow it to be added to this. In this case, we're saying, no. All of the list of rule classes that you're allowed to add this theorem to is empty. So we know that it is true on its own. It just goes and lives off and being a thing we know is true, but we're not allowed to use that for anything else.
So
unless,
it's not part of any group of rules. It's going to automatically try to
that's right.
apply unless we tell it to apply.
That's
Try
right.
it. Okay.
Which comes up down here.
Okay.
So just go back, the first 6 lines aren't done yet.
Oh no, this is done. So this one to here. Yeah. So this symmetric greater than or equal to integers implies equality. This to here and here. I should have tried to figure out how to.
I don't want to hold everybody up, but I'm still lost in how you convinced you of the.
Oh, once we gave it the, without the rule class as nil, just saying this, that the integers and the other part makes it true. It was convinced that was true just from that. It was able to do the proof automatically at that point.
Just by structuring it this way is what.
Yeah, just by adding the integer restriction on it.
Got it, okay.
That was enough to do it.
So
Where
can you agree on that it's adding the integer restriction?
For this particular piece,
Okay.
yes. Yeah, this piece required adding the integer restrictions.
Yeah, don't want to hold it up, but
Yeah.
didn't it already require them to be integers or no?
Not previously.
Okay.
Yeah, and that didn't, and our original definition didn't. We never said anything about integers. I certainly was thinking about this as being integers. And it's interesting to see that this is still true even if we don't know it's integers.
So it's effectively there's like untyped numbers is what it was going in as.
Or it might not even be numbers. And so that's the weird thing. Max, we're thinking about this as being numbers, but in a sense, even if this was somehow like a list or something, if you had greater than or equals to on something that wasn't the number for some reason, this still works on that, whatever that is.
You know, stop me if I'm asking
Yeah, yeah.
questions, but, so basically you just said, so it's integers, and then I could take it from there.
Yeah, once I say this thing is integer, so if we go back, we can see, where was it? There. The thing that it was complaining about is a slightly different version of it. This was the less than or equals to instead of greater than or equals to that it was complaining about. This thing didn't like the less than or equals to part. It was like, I figured this is the problem that I'm running into, but I don't think this is true. And that's the trick, is if we don't know that we're talking about integers, then we don't know that less than or equal to and greater than or equal to together mean that something has to be equal.
And I was to go out on a limb and guess that you could likewise say something like, assume these are some kind of object that has a total ordering on it.
Yeah, in a sense,
And
yeah.
then be able to take it just as if they're integers.
Yeah, for example, in this case, we were saying that, this thing isn't convinced that the things that we're comparing have a total order on them. In this case, we're saying that they're integers, since integers have a total order, but equivalently, we could say something, have a thing that's an integer p, we said total order under greater than p, and that would be enough. That would be a more generalized version of this that we were looking at.
Awesome.
And so
Question?
yeah, this was all true until and then the rule classes thing was just so that it doesn't break things. Yeah.
So if I was trying to prove that on paper, I'd split it into 3 cases where, you know, x is greater than y, x is equal to y, and x is less than y.
Yeah.
So would it be able to do that if you kind of like hinted somehow that it should break it into 3 cases?
Yeah, so, in fact, that is what it's doing under the hood.
Okay.
I was gonna assume it like effectively did that once you
Yeah.
gave the total.
An earlier version of this, because I wasn't sure if that was maybe part of the problem, an earlier version of this that also solved the problem, I did put that hint in there. I said, hey, here's another hint. When you're getting the goal, not only do I want you to use this thing I proved, I want you to think about it as being the different cases, like a greater than, less than, or equal to. And it was like, oh, okay, yeah, now it works. But then I realized, well, if I remove that hint, it still worked. Because that's actually what it was doing under the hood, so.
Okay.
So the only part that I needed down here is this one from here. But yeah, you're absolutely right on that though, is looking at it case by case is what was required to make this work. And the trick is, it's the equals part that was broken. And in order to get the equals part, you needed this other component. Yeah.
Why again did you tell the classes now something about preventing this from being extended to everything else?
Yeah, try and prevent this formula from being applied anytime we're ever talking about integers. Just the way that it goes through the search tree or whatever can break things. So, yeah.
Okay, so then you use it for the next part.
Yeah, and so that's why we had to explicitly add it down here. Yeah.
When you say it's a hint, for the goal, is the goal like usually just what the endpoint of this theorem is supposed to be?
Yeah, because you could have things other than the goal that you wanted to use it for. You could get into some other specific aspect.
There's no like special token for that, we just use the strings.
Apparently.
Okay, cool. I noticed because you have a space before the goal unless like.
I think that's just LaTeX getting confused. I put code here, and I think LaTeX thought that it was supposed to do something.
Okay.
Yeah.
So, alright, cause I got real scared of that.
Yeah,
space.
yeah.
If I can summarize what happened here, it's like, you first told it was integers, which was enough to get this lemma, and then giving it the lemma as a hint was enough to prove the rest of the theorem.
Yes, that's right. Yeah. Yeah, telling it was integers was enough to prove the lemma, but then it wouldn't let me add the lemma because adding the lemma breaks the crap out of integer stuff. I told it, okay, prove the thing is true, but don't add it to the default list. Okay. And then down here, I have to add the integer restrictions on here, because if you don't, then this thing doesn't even apply to it. But once you've added the integer restrictions on the max2 commutative, then, and then explicitly say that we want to use that one that we said don't use it in general, then it works. Yeah.
Do you care to speculate as to like how it derives the lemma that would be convenient for it?
So you can have it explain that to you. By default, it's kind of verbose. There is a way that you can tell ACL2 to be extremely verbose. I'll need to look it up.
Yeah.
But yeah, it'll tell you everything it's doing,
Yeah.
and it's a lot, but you can see what it's doing. Yeah.
Well, it's interesting because it's like, it could at the very end to like just have the thing that it like the last conclusion
Yeah.
was able to.
The thing that it's having a hard time with. Yeah.
Yeah, and then it could just be like, hey, or like, input plus the last thing I did, if that implies your final thing, then that would be really convenient.
And that's kind of how Isabel does its output. But I think that's more important with something like Isabel because you're potentially using higher order logic instead of just first order logic.
Yeah.
It would potentially be instructive here, but I think that's the trick is you can get it to say that level of verbosity.
Yeah.
But it's probably not as true that it's hard to figure out what is even happening without the rest of the context, like for Isabel or Rock or Lean or whatever. You may actually be lost because it's doing higher order logic stuff, so you may not know where this thing is even applying in those kinds of systems. So yeah, and we can play around with it a little bit more here in a minute. Okay, here we go. So the ACL2 workshop is going to be on Monday the 12th and Tuesday the 13th of May. The night before on Sunday, they're doing a get-together at a pizza place. On Monday night, there's like an official conference dinner. I think it's just part of your registration fees or whatever. And there might be something Tuesday night as well. So if you are around, it's a cool thing to go to in person. If you can't, they've got it online so you can watch. I assume they're going to record, but I couldn't find the recordings from last time, so maybe they didn't record, I don't know. So registration is $200 now, which is more than I was hoping it would be, but I had already registered, and it was a little bit cheaper. But yeah, it definitely includes the snacks and stuff. I think it's like they will try to get a t-shirt, but it might be too late kind of thing. So the topics, they've got the schedule up now, and so there's a variety of things. There was one of the guys is doing a formalization of linear algebra, which is kind of an interesting setup. He's doing last time he did abstract algebra, and it was not like the easier theorems. These were the less easy theorems that he was doing. And so I'm going to be curious to see what are the nasty bits of linear algebra he's planning to do this time. He called it elementary linear algebra, but knowing the particular professor, I think elementary to him might be like completely like I have no idea what's happening. I need to take notes and look this up like later to even figure out what words he's using. Like, so it'll be interesting. They're definitely doing some industry use case stuff as well, but again, particularly in hardware verification, but there's a few others as well. And then kind of an overall state of the community. This is kind of their main community conference, so things about the state of various proof libraries, which in ACL2 they call books. The way these different library kind of like module systems work is in order to keep the state from exploding too badly, they kind of try to isolate what are all the pieces that have to be related to each other into separate chunks. And you know, you could argue whether or not it's a good idea to include all kinds of things inside of your code for a different programming language. But when you're dealing with an interactive theorem prover, you do not want to be including stuff that you don't need, since that will potentially keep you from being able to make your proofs because there are too many things in that state. So they have them kind of isolated in that regard. But you know, they've got a bunch of different ones, and so they're going to be talking about which ones people are working on, and which ones people wish existed and don't exist yet. There's some of the people who run ACL2, like the main maintainers, are definitely into retirement age now, and so trying to get, figuring out who are going to be the, going forward, the maintainers and things like that. One of the things that's kind of interesting, because the way that ACL2 works is they actually have books for all of the content from the talks from all of the years that they have ever done the ACL2 workshop, It's just built into the source code. And so some of it's already up for 2025. You can just go and look in GitHub and see code for talks that haven't been given yet. They're just sitting there. Go poke around and see what you think. And I will point out.
Can you go back to that slide again?
This one? Yeah.
Yeah, thanks.
Mhm.
You got it?
Yeah. And I will point out once again, the coolest demo I have ever seen, was at the last ACL2 workshop, where they pulled up a brand new MacBook Pro, because that was the only thing that could even run this thing. And they had built an entire x86 processor inside of ACL2. The whole thing. It wasn't a very, didn't have all the bells and whistles of later x86 processors, but it was to spec an actual implementation of an x86 processor. And then they ran Linux inside of it on that fake processor, which has never been done before. And it was pretty wild. It had a really basic in-memory file system with a couple of files, and they typed ls, and they pressed enter, and then it was just like a screen full of parentheses for 5 minutes while it was trying to figure out all of the system calls, all of the all of the different circuitry inside of the processor, inside the x86 processor that would be involved with doing something like that. And so it was wild to see that. And apparently they are going to have a follow-up this year. I don't know what they're going to do, but they're doing something apparently. And that project, I guess they have been working on since the 90s, where they have slowly been building up this processor. And so then last year was the first time they were able to get Linux to run on it. And the Linux did not know that it was inside of a special computer. In fact, it was just a really, really terrible old x86 computer. It was wow, I don't have much memory. And it's it's not even a power of 2 or something. It's the least amount of memory that would be possible for my thing to run. I wonder why that is. So it was pretty wild, and apparently they are going to have a follow-up this year. So even if you can't attend in person, it might be worth getting on that free registration and then jumping on right before they go do whatever shenanigans they're going to do this year. I don't know what it's going to be. So that is the end of the regular part of the talk. Do we have any other questions, or do we want to go dig our head?
What's the case for learning this thing over rock or lean or something?
So one part of this is because it's heavily used in the hardware industry, if that's something that would be of interest, that would be that's a reason to potentially get into it. Again, it's not used for, it doesn't have higher order logic capabilities like Lean or Isabelle or Rock would, but if what you're doing is entirely in first order logic, some of the tooling that they have built out over the years make it a lot better if you have a really, really big first order logic problem. And that's part of why it's popular with hardware. I haven't gotten into a lot of the guts of what that would look like. I think it's kind of bespoke at every single place where they have that kind of a problem. But from talking to some of the people who run Isabelle and Lean and Rock in the past, they are all very happy that they're using their interactive theorem prover and not ACL2, but they are all very jealous of ACL2's abilities when it comes to, hey, we want to do a verification of an entire processor in single step. They actually have the tooling built out to do this efficiently at scale with ACL2. And they're all very adamant that we would like to be able to do that one day, but we're not doing that today, and all of the other ones, for example. So it's like if you have a problem where first order logic at a huge scale is your problem, it's great for that. And if that is not your problem, maybe that's not the tool to use. You can still do a lot of things with it, but
So the case is basically that it scales really well?
it scales really well for that particular set of problems, yeah. I'm still a lot more comfortable with Isabel. That's kind of the one that I have mostly stuck to. I've seen a lot of lean code, and that looks great as well. And I know a lot of the people who do like programming language design and trying to come up with properties around those systems prefer to use Rock because it's maybe even stronger guarantees than you would get from Isabel or Lean out of the box for certain kinds of things. But yeah, so in a sense, it's like, in theory, you could use any of them for doing the things that ACL2 does. And ACL2 can do a large chunk of the things that the other ones could do, given enough time. But in practice, they're used for very different things, so.
Cool.
Yeah, other questions?
Not a question, but I just found a GitHub repository with examples of proving left pad in a bunch of different theorem provers, and I'm gonna post some soon. So
Nice.
if you can look at that.
Let's get, okay, up here, come on. Let's just close you. Make a new tab. Okay. And ACL2. That's probably not big enough. There. Is that big enough? Or one bigger? Okay. So we can type defun max2 xy and if greater or equal to x1 x otherwise y 2 parents, right? Okay, so this the one we already saw, so it's admitted the definition of max 2. So now we can do our def theorem, max 2 at least x. Okay, and we'll make that be greater than or equal to max 2 xy x. Yeah, we got QED, so I'll work too. Okay, and then we'll try our we'll do our original one. Def theorem max 2 commute, come on, iterative. Okay, and let's do, so that is equal max 2 xy and that's gonna be max 2 yx. One more. And didn't like that. And so so we could just try to prove that one without doing the anything. So let's do def theorem. Let's say LE implies EQ, whatever, doesn't matter. LE IMPL EQ. Okay, and that is going to be implies and less than or equal to yx less than or equal to xy equal xy. There you go. So that. Okay, and it didn't like that. So, but we could add our, so we got y is less than or x, like less than or equal to x, x is less than or equal to y. I don't think there's like a total order p. I don't think that's a thing. We could say something that all
Or is, well, like, I don't know, it's cheap, but like before intelligence integers and it figures it out, or
yeah, yeah. One possibility, yeah, if we could accept as an axiom that everything is either that either x is less than or equal to y, or y is less than or equal to x.
maybe the three possibilities.
Well, in this case, we wouldn't even need that much. We would just need the saying that those two things have to be both true. In a sense, just saying that they're comparable. We don't even need a total order. We would need like a.
Sorry, what was the
So what is it? So total order is everything is comparable, but it has a few other things. Is total the only one where everything is comparable?
I don't know.
Is it? Yeah, because a partial order would imply that not everything has to be comparable at all, right?
Is that true, or is it more about whether like less than is like transitive and stuff like that?
Yeah, because that's what I'm trying to figure out. Like, because if we don't need like transitivity and such, if everything is comparable but we don't have to have transitivity, there's probably a name for that, but I don't remember what it was.
That's a partial order stuff, isn't it?
So stupid question, what about like breaking less than or equal to into, you know, or less than, or, like, the or less than equal?
Yeah, and that would be fine, but then we would still have to know that everything was comparable with less than.
So really that's all that's holding it up from automatically doing, is just knowing that they're comparable, no?
Yep.
Oh.
So the integer thing solves it, but.
Also, there's a whole paper titled "Adding a Total Order to ACL2" apparently. So apparently it's there. I just don't know what the function is.
Oh yeah, there's definitely like libraries and things that you can add that would get it. So.
Yeah, it seems like it's included within ACL2, but
Yep.
yeah.
Well, it ships with it. So you've got all these books and stuff. Like you say, unlike with a lot of other programming languages, they intentionally aren't including a lot of things out of the box. Like they're all there for you to include if you want it, but they're not included out of the box by default, so that it doesn't make the state space explode too bad.
Yeah.
Why is the error that's saying that x, that you're doing a rewrite on symbol x?
Oh, and that okay. That's actually has to do with the other part, that rewrite rule stuff.
Yeah.
So before it even got to the truth of this one, I guess it was trying to evaluate that. So we could okay, let's do that real quick. So okay, but before we do that last paren, we'll do our colon and what is it? Known as rule class is nil. That's right. Rule class is nil. Okay, there. It was looking at the rule classes thing before it was doing the actual proof. So.
Yeah.
Yeah, it's like, okay, cool. We're not worried about the rule classes thing. Here's the thing I couldn't prove. the statement we started with. And I don't think it's the kind of thing where you can just pick one or the other, so let's try that. Integer p x. Just saying that one of them is. That, and then that, and then we do our little classes now. Yeah. So, that was actually a little bit helpful here, because once we knew the integer p on x, so we knew that x was an integer. Now it's saying they can't establish that y is an integer. So that would be enough then.
Yeah.
So now we do it one more time. We add integer p, y. False, and we do our rule exclusion. There we go. Got our QED now. And so now, if we want to do our commutativity thing, we should get the same problem we had before, because this isn't in its list of acceptable we'll just type it faster. Max 2 y x 2 3. Yeah. And that now it's only because that one isn't in the lookup system. So now so we do our def theorem there, equals max 2 y. And we get rid of this last one. Okay, now we do our hence.
Yeah, oh, it's in there.
Yeah, yeah. Goal. And we could do the cases thing. Cases, so we got less than xy, greater than xy, and equal xy. Do I have to put another set of parentheses around those? I don't remember. I feel like I probably do. Yeah, I suspect I do. Let's do that. Okay. I think each of them wants one argument. And then we do use, and what did we call it this time? LE implies equals, okay. LE, IMPL, EQ. Well, we could leave that out for the moment. It'll fail again, but you can see that it fails. Not a friends. Not a friends. Okay. Yeah, it's still complaining, but then we go def theorem next to commutative. Okay. X. That one. So after that, then we also do use LE implies equals how many prints do we need? So that is another one for the goal list. So why did this one fail?
Yeah, X not being, no exception.
Yeah. So if we look, our, let me scroll back up. What did we actually say?
Or did you not?
We
put
didn't.
the-
For our max 2 commutative, I didn't add the restriction of integer p for x and y. As a result, I can't use this theorem because I don't have, you know, it's like maybe it wasn't integer p. So now if I, but the other aspect that's kind of interesting with this, I can't just say that it's true. I just have to say that if it's true, then it implies the rest of it is true. So, so instead of going directly to equals here, I need to do a implies, and we're doing and. Implies, and now I can do the rest of it. And now QB. Surprising that typing crap about integers one at a time is how you eventually get to a whole x86 processor. In fairness, I know they automated a lot of that, but still, quite the feat.
You know, it said at the beginning something about it like being trivial because it wasn't recursive. Like what happens if it is recursive? Like we type in a simple definition of Fibonacci here.
Okay.
It's gonna just.
Yeah. Let's see. Define. Okay. Fib. And okay. I'm gonna use cond for this one. Cond. Is it nilp? I'm trying to remember inside of it. It's all the different lists have slightly different ones. Was it?
You're trying to say that
null? Is it
if
null?
N is 1, then we return 1.
Oh yeah, that's right. It's yeah. In this case, yeah. So it would be okay. Yeah. So that would be equal 0. Oh, we want to do integer as well, right? On the ignore all the questions about the.
Yeah. Yes.
So you're gonna mess it up?
Yeah. Let's just ignore. Okay,
So
implies.
you're defining Fibonacci's.
Yeah. Okay. So it'll be integer p n. Okay. And so we're gonna do from there. Now we're gonna
Do
do
you
cond.
need another parenthesis?
Yeah, I will hit here
Okay.
again. Yeah.
So you say 0 to 0 or you start
Equal
with 1?
0. Yeah. Well, I don't remember what their integers start with. If it starts at 1, it'll explode. So then it'll be integer.
It needs the 0 though.
So that will be a 1. So it's 1 1 and then 2 3 5. So we'll say cond.
And then if it's 1, it's
0 is 1. And if it is equal, yeah.
I wondered if you had to specify the variable.
Yeah, definitely do. 1 n. That'll be 1. reverse it, yeah.
It's the fib of n minus one.
Yeah, plus, plus fib.
Plus fib,
Yeah, so
yeah.
I did plus,
Yeah.
fib, and minus one.
Yeah, plus, fib minus n1. Okay, number of parentheses, another parentheses, okay, that closes the fib. Okay, and that's fib minus n2. And then just a bunch of parentheses.
What are you doing there with the t? You declaring a new variable or?
Always true.
Ah, okay.
Yeah. So this, the way cond works is it takes several different pairs. And the first item in the pair is something that's gonna give you a Boolean when you evaluate it. So it'll either be true or false in the case of ACL2 apparently. It'll
So
be
that's,
null.
so we're equivalently making that like the default case.
Yeah.
Just take that.
Okay. And so then the second value is what will be returned if the first one returns true. Okay, so how many parentheses do I need? So I need to close fib, and then I need, well, okay, n minus 2, okay, fib plus the t condition, okay, implies, and then definition, so 7 parentheses. 2, 3, 4, 5, 6, 7. Okay, yeah, there we are. So an interesting result. It wants us to give us a sense of measure. So it wants us to tell ACL2, what does it look like if we're making progress? How do we know that it eventually terminates? So you can get ACL2 to tell you it terminates, but I think it would rather not. It would rather you tell it. And so it wants us to introduce a measure. What?
Inductive proof.
Yeah, it
I don't know
wants
the
us.
concept of a measure.
Yeah. Our heuristics for guessing have not made any suggestions, so it will try to figure out what the measure
So it's
should be.
basically asking us, okay, fine, saying like, okay, fine, there's a Fibonacci thing, what do you want me to prove about it? Is that what it's saying?
No,
They want to-
it's not accepting it because it doesn't know how, it doesn't feel comfortable with the level of knowledge it already has about the system.
Okay.
Yeah, so it's not accepting this.
Does it know it's already defined only on 0 and above integers? Cause you told it was integers, but I don't know if that allows negative.
Yeah, it doesn't look like it was. Oh, that could be it, yeah, that could be it. It could be because it didn't see negative numbers, it can't figure out what the measure would be. So if we did natural P instead, maybe?
Or you could add a cond that says that if n is negative, return 0. It's defined, but it's just 0 up until.
0, yeah. Okay, let's try that.
Or you could play around with a lot of things, but
Yeah.
you see if n is negative, just return the same value as a positive.
How do you specify a measure?
It's another one of those colon directives, kind of like we had the hint and the use and stuff like that before.
But it invokes a measure in order to guarantee that some.
You would define what the measure would be in that case. So you would give it some function, which you said, this is the measure for.
The property that function is supposed to have is that the system can use that to prove that it is approaching a terminal case.
Yes. Yeah.
So could we just like prove that n is getting closer to 0?
Yeah, for
Or
example.
like provide a measure that is just like split for n, and if it's continually decreasing, then like you're gonna stop.
Yeah, yeah. So yeah, let's do less than n0, and we'll say it's 0. Okay, yeah, let's see if that makes it happen. Yeah, so in that case, But it does make me wonder, though, as we were saying, is it natural P? I'm gonna guess. Natural P.
Natural.
Okay.
I don't know if there's a symbol for natural P's.
Yeah.
It's different.
Is it natural?
Is it nat P maybe? I suspect they have one, because it comes up often enough, especially the things that you're dealing with, interactive theorem provers. Okay,
So it's back, it took it, but it's back to saying.
yeah, but it still wants a measure.
Well, wait, sorry. Isn't this an if statement and we're not doing anything in the else case? We're saying if it's a natural number, this is the definition, and then there's no otherwise?
You're saying if it's a natural number, then this follows.
Yeah.
But we haven't defined what the returns if it's not a natural number, or are we not obligated to?
It's
Oh,
not an if statement, right?
It's not an if statement.
It's a
Yeah,
implication.
so I was constructing it like a theorem, because implies is what you would need for a theorem.
Mhm.
In this case, it's not a,
It's not a theorem, it's a function definition.
it's not a theorem, it's a function, so we're saying that it has to be true.
You're saying if it's a natural number, then it's the regular Fibonacci, and if it's not, then return something else out.
Yeah. Okay, so let's try. Let's try this. Okay. Not nat P in. I need one fewer parenthesis.
Parentheses mistake. Maybe the GUI can help with that.
Are you sure you need to add that parentheses at the end?
I need no parentheses here.
Gotta start with a function name.
Oh, yeah. There was. Yeah, so that was it. It was because we couldn't, implies, doesn't make sense in the context of a function. You guys are right. It is what you would do for a theorem, but it doesn't make sense in the context of a function.
I forget, were we trying to prove that, did we have an idea in mind for something to prove about? Or we just wanted to check what happened?
Yeah, we can
I just wanted
evaluate
to
it.
see it accept something that was defined recursively.
Fibonacci 1.
I was expecting it to complain about that or something, but
One.
we're fine.
That's 1, 1, 2. Let's do negative 1. Give us a 0. Okay. 1, 1, 2, 3. Okay.
Awesome.
My always go to little tiny fun theorem is f prime squared minus 1 is divisible by 24.
Yeah. Okay. Prime squared minus 1 is divisible by 24.
Because you can always rewrite it as p minus 1 times p plus 1.
So it's not prime P. We have a. We could implement prime P, but.
Is there a factorial?
Or is there a, check but if you're hoping that prime p just is a boolean.
Yeah, I was hoping it was a built-in.
Yeah. Yeah, if there was
How are we doing on time?
a factorize, we could,
Is there like a
Like
divisible,
more
or
than two
like a,
I mean, we could, yeah, we could certainly create one.
but we'd have to write like the C thing.
Yeah, and then we would have to do proofs about the prime function, about a prime checker terminating. Which we could do again, but like, it's already 8:30. But yeah, I mean, that's the thing, absolutely, you can do, they're able to build a freaking processor, I guarantee you can do that.
Yeah.
You know?
Yeah.
I have that, book, I should have brought it, I didn't think about it, whatever they call it, 17 Provers of the World, and ACL2 is one of them, that they describe in there. And so, need stickers or pass, So, yeah. It's an interesting area of something to play around with, so.
yeah.
I know that theorem.
You can always write it as p minus 1 times p plus 1. And primes are not even, so p minus 1 and p plus 1 are both even. But also every other even number is divisible by 4.
Yeah.
So there's 3 factors of 2. And then also, either p minus 1 or p plus 1 has to be divisible by 3. Because p minus 1, p and p plus 1 are 3
And prime numbers itself, the one that
So
is.
Yeah, p isn't gonna be the one that's divisible by 3.
That's how you get 3, 8, and thus 24.
Uh-huh.
It's pretty hot one.
That's gonna
So
keep me up straight.
so if anyone's interested in going to the ACL2 workshop, hit me up. Also, the NASA formal methods is going to be in June. That's it. And so the question is, what do we want to do for a talk in May? A little bit tempted to see if I can get one of the speakers from the ACL2 conference to come talk. We've had a couple of them in the past who indicated they'd be interested in coming, but we don't necessarily have to do that in May. We just did the ACL2 stuff. We could do something different. We could do TLA plus. We could do SEL4 stuff. Any number of things. Is there a particular interest?
I'm personally interested in like TLA plus and
TLA
like
plus? Okay.
separation logic stuff, I guess.
Yeah, we could do a TLA plus first, and then we could do a separation logic in like a couple of months or something. Thanks for coming. I'd love to get guest speakers on some of these things, but some of it's just going to be depending on when people are in town or whatever. Yeah, TLA plus would be a good one. I've actually been paid to do TLA plus stuff before, so that was fun. And TLA plus also unlocks getting to talk about FRET, which is a NASA tool which you can use to try to help non-programmers come up with TLA style specifications. They're not limiting it to TLA plus, it's just temporal logic in general. They've got a GUI tool that they use at NASA that tries to convince non-programmers to describe what it is they really mean using temporal logic.
I see. It's interesting because I'm interested in like specifically like proving things about like distributed systems, and so like
Yes.
TLA plus is very interesting for that. Like, I've seen like I don't know if you've seen, like there's a really interesting paper called Iron Fleet that's like using like Floyd-Hoare logic for proving stuff about like the machines, and then or proving correctness and safety, and then using like TLA plus for liveness guarantees about like the algorithm. It's like that's very interesting, but that's sort of the only formal stuff that I like actually know about.
Yeah, no, it's a good area, yeah. And speaking of Floyd Hoare logic as well, that's another one. At some point, I can give a talk on predicate transformers, like weakest precondition and such, because that's how I got started into this stuff.
Okay.
And so that's using Hoare logic to do program extraction and things.
Thanks
like that.
again, Charlie.
Yeah, thanks for coming. So yeah, if anybody's not in the Zulip, let me know and we'll get you in there. But yeah, thanks for coming out.
Last night, Charlie and I were like, you gotta beat Rob. And that's Rob.
Oh. Well, that was Tuesday night though, right?
That was last night.
Wait, it was?
Tonight's
Last
Wednesday.
night.
Oh
Tonight's
shit.
Wednesday.
Oh my god. Well, how did
He's new in Austin. He used to like write drivers for work. Think about drivers.
Yeah, I mean, it wasn't like super low level stuff, but I mean, it did control a Ethernet basic or Ethernet switch basic, but I'm not doing it anymore.
What are you doing? Are you looking or?
I will be looking.
Yeah, you're good.
But anyway, I need to catch a bus, so.
Cool. We'll stay in touch though.
Yeah, I'll talk
Oh,
to you
we've
later.
had some up here.
Do you need any more?
Jack, you go to the food things, don't
We've
you?
got enough.
Yeah.
Okay, cool.
But
Oh, okay.
do you want me to just leave the extras up there?
Yeah,
I'll be there on
Yeah.
Friday,
Thank you.
if I remember
Yeah,
which day that is.
Yeah.
You know,
I guess he wasn't employed that fact he didn't know what day it was. I
yeah.
envy that, really.
Yeah, that's a good piece of deductive reasoning there.
Yeah.
Interesting. I think he quit his job previously.
Yeah.
And he also just moved to Austin previously.
Yeah.
Yeah. But
So what do you do?
Oh, yeah.
he was doing a bunch of like
I'm
C,
about
C++
to
stuff.
graduate UT Austin,
His
and
last gig.
I'm
he
thinking of
sounds
doing
like
a
he's trying to
PhD
get
in like
into,
formal verification stuff, but I also
methods
don't
and,
know like if I will. I'm gonna work with Cloudflare
Oh,
a
nice.
little bit,
Yeah.
so
Mhm.
we'll see.
Nice.
I really like distributed systems and
That's a
stuff,
really
and that's
good-
like my main thing.
Mhm.
And formal verification is like sort of the other thing I like.
Mhm.
And so I actually got into like a PhD program in Wisconsin medicine.
Oh, yeah. I hear that's a really good school.
Yeah, it was like the only school that accepted me, but I was
yeah,
like, oh, they do some really
you been
cool
good lately?
systems, like
I've been
verification stuff.
busy.
Yeah.
But
Yeah.
because of like funding and stuff,
Yeah.
I was like sort of forced to defer. They
yeah, it's gonna
took away
be
my like
busy.
funding guarantee for my first year.
That's
So they were like, we
Is he
could
doing
guarantee you funding if you
good.
come like later. And I was
Oh,
like,
wow.
you know what, sure, I'll
You'll
stay in Austin for a little bit, see what I can do.
not
Yeah.
to live with
I-
one, definitely like.
Honestly, I might just
round
continue
most
just working
people.
at Cloudflare. I don't know. Like, who knows?
Like, yeah.
Yeah, I feel like they do really fun like distributed
So
stuff.
anyway, but
Yeah,
I
for sure.
what about you?
I need to finish
I work
some
at
things about my
WPHM
house,
with Charlie,
both
and
to-
so
Oh, okay.
I work in like
to get it out of
Kubernetes,
Kawhi
and
and
Relay,
shares.
kind of stuff, so
So,
distributed
I've got
system.
those contractor
Neat,
days
neat.
on the porch. and
How did you get into formal stuff?
Charlie got me into it, and yeah, I ended up at a NASA Formal Methods conference
remember when I asked
years
you
ago
about
now,
the
and
duplexes
I
and
can't believe it's
duplexity
been that
where
long,
you-
but
Yeah,
I didn't
yeah.
understand
I and
anything.
my brother had thought
And
about.
yeah,
maybe
so I'm
buying
building a
like-
satellite
Yeah, I remember you
that's
mentioning
at the
before
university
that,
right
like,
now,
you
and
guys
so
figured
yeah,
out
yeah.
which
And,
sibling is gonna.
it would be really cool to improve that system. We're not going to.
Well, then sounds like
but
work.
I want to
Yeah.
be
But
able to
he's,
do that kind of thing. So.
actually, I
Yeah,
would
yeah. There's.
love to bring
Have
into
you heard of like
that.
pharmacy or something like that?
Pharmacy?
Yeah,
Yeah.
Because I recently heard
Okay.
about that. And I was like,
Yeah.
oh, that's really because
But, yeah.
the only things I've really used are like Daphne.
He's-
If you've
Yeah,
heard of Daphne.
I have heard
Generally
of that, but
kinda
I don't know
struggling
anything
at,
about it.
It's like it looks like JavaScript C# sort of
Really?
thing.
To,
It's from
go out
Microsoft and
Oh.
it's
get
this like
involved in the
imperative
actual stuff
language
like
that
We'll see.
Yeah, well, it sounds like
compiles
it's good
to
that
C#
it'll be
or
around
Java.
US.
Also, it
stuff
seems
like
he's
that.
like, a lot of people like.
It's pretty cool.
Yeah.
The people
Yeah,
who
my dad's
made
that way.
it realized that
Limits. Yeah.
So
it's
they're
much
actually
easier to
sometimes,
use like linear type
Mine is
systems or
got
whatever
type
to
today.
prove things about like lower level like systems properties, and so they made something called Veris for this. It's like verified Rust.
Oh, wow.
And
Wait,
so,
seriously?
so that's like a thing
No more,
that's coming out of
on the
like,
Apple stuff.
one of the people was working at UT. There's a few others everywhere else.
No, I mean, I
And,
applied the Apple thing, they
I think it's
confirmed
really
during
good.
receipt,
Yeah, it's like
right,
the
and
Floyd Horror style, like
follow up with it,
logic,
whatever,
but in
and
Rust.
Oh, wow.
It's
Probably
very
would
new.
that
It's
off
very
to
like
get moved, and then
I don't know how much of the standard library is
trying
like
to start a new job at the same time.
supported yet or whatever. They have their own like
Yeah.
formally proven vector or
But,
something. But it's
my other job,
it's really cool because
you know,
the way
could go
that sort
away
of
with
Daphne works is that it gets around a lot of like problems by being like, well, integers are just
pretty
whatever,
stable.
they're unbounded.
Mhm.
And in Rust, it's like,
Zero
no,
on
these are
GPS stuff.
64-bit.
Mhm.
Like, actually, almost every
You were
function you
mentioning that
do
you
has
tell
to
me
check
that
for
yeah.
overlays. That it's much more painful, but it's
Wow.
it's also
Yeah,
like
that was,
you prove actually interesting
That
stuff
was a
here.
disaster,
Yeah.
trying to get
Man, that would
little
be
stuff
really
as
interesting to
possible
build
for
a satellite.
China and overseas, but.
Daphne's?
No, well, this Veris, with the.
Oh, yeah. Verified Rust, yeah.
Mm.
So,
Yeah.
Yeah.
Because I'm targeting microcontrollers, so anything that
Oh, there's a new.
targeted microcontrollers, that's good
guy
too.
you've been working
Yeah,
on.
that's really cool.
Yeah,
I mean, you can use something like Primacy or something for that matter, so.
yeah. I don't know,
Is he
like,
into a LLVM?
it weirds me out, the
Not directly,
Um,
but he partners
the
with somebody
JPL
who's done
conference
some,
that
like,
we went to
maybe
on,
customized
their
stuff for people.
satellite operating system.
Which most of his background has
Oh,
been doing
F prime.
bioinformatics
Yeah,
stuff.
Is,
as a consultant,
like they spent half the talk, I
He
have not
was
grown
all
up,
for
writing C,
all, like,
so, but they spent half the talk like,
Yeah.
little
uh,
consultancy,
yeah.
and it's
describing all
mostly
the ways you
processing
can go
and
wrong
analysis related
in
to that
C,
stuff, but
and I'm like,
Yeah.
I
also
just
kind
don't
of
wanna live that life
all
when there are
music
other
sort of
languages and
becomes
tools that I can use.
Yeah.
research system of-
I spent the last year or so
And he
just
also
writing in
teaches,
C, and
Yeah.
it's been very
online class.
painful.
just for,
Like,
Yeah.
like Linux kernel modules and stuff. It's like, oh.
I kinda wish
Yeah.
that I
He's
had
really
a
interesting.
reason to do that, cause then it would really
Very,
push me to
very
feel a little bit more
broad
comfortable.
knowledge experience all over
Mhm.
that place.
That's totally fair.
Yeah,
Maybe
I don't have a reason, and I'm just gonna use it to.
Yeah, I've been
I use
recently kind
anything
of like
else.
focused on
Yeah, I will not use JavaScript.
The only C code base that we had, you guys got rid of.
Not yet. Oh man, we're so close. WP Engine X
That
is
is
so
like
close.
running at least like
It is
20
really
miles
nice
a
though.
Yeah.
It is definitely a step in the right direction.
So Charlie, they
Around
rolled it
these
out
times, and I'm like,
everywhere,
once I get these
and then they
things
had to roll it back.
Yes.
So
Step is it reintroducing
Yeah.
Go to the space.
Is Caddy written in
Cool.
Go?
Caddy's Go, yeah.
Okay, okay.
I don't know if
Because I've used Caddy.
this
and it's
weekend
like
there's a
pretty
Go
nice. I
tournament
don't know.
this weekend, but next weekend my parents.
I
are in
imagine
town.
it's slower.
But
than it is
so I
exercise. I don't know.
probably
Imagine
did
there's like
something for a
reasons to
while,
not use
but,
Caddy.
But
Interesting.
do you guys know
Yeah.
progress on
Well,
or it's like still?
I think
at,
Engine X still is faster
radio
or something,
and,
but that's like, I don't pay
I
attention
should
to that
propose
stuff.
that we
Yeah.
have the next one at.
This is sort of random.
That'll
One of
make
the
it
things
easier
that
to
I've
go
been
through
Yeah.
is like formal
I'd love to
verification is
fight.
hard.
Mhm.
I think I
We
can fight
like
from those types of
kind of the
things.
main reason everything isn't formally verified is just
That
it
would be
takes
cool.
too long.
Yeah.
And then there's all these people who are like generating code with LLMs now.
Yeah, yeah.
And it's like one thing I've been interested in is like could you like
Stuff or
fine
whatever.
tune an LLM to like be better at verifying stuff? And it's like I imagine you totally could. And that would be
Calvin's
interesting
actually gonna
because
fundraise when
if
hope he's right, 'cause
you sort of have a
we're gonna run out of
specification and
payroll
then you
in,
throw
like, at the
your
end of May.
code with your proofs to an SMT solver.
I
and
think
it's
he really wants to
yeah.
do it like a
Well, then you
small
actually don't
chunk
even
at
need to
a
look at the
time.
code the LLM generates.
I've been like
Potentially
banging
you
my
wanna
head against the
specialize
bug.
on like reasoning and
I don't know, there's all- there's
final
just-
Yeah, there's like the O1.
What'll be cool is
Oh, sorry.
I was just saying, even before that, there was a, like a time when I had this like,
where we have the rest
there's
of
this
the
game on
Just
Steam
like a whole.
called Turing Complete where it has its own special
I feel like
machine
we're kind
code.
of cheating
Oh.
by saying
And I
we
just
have rough
explained the
code.
machine
Like,
code in English.
we've
and
definitely
what
done
it's
all
like
the hard
indicates,
stuff,
Mhm.
but
play it
like,
in English, and asked it to write a program.
if
It's
you're
still
doing
doing
like,
Okay,
I'm like,
yeah.
JSON,
I don't know, something's going on.
like HTTP.
Yeah,
You're
so
doing
it's like
HTTP.
I've been getting more interested in like
Basically, like the way you
using
serialize it
LLMs
is
for
with like
generating
a
code, but
crate
it's like
that,
I just like don't trust them
uses
yet
macros
for like actual. And it's like
and
so I've been
macros.
I don't know. There's like
current
relatively
setup,
small like models that are decent at generating code, and it's like
Calvin's like done a
it's
decent
not
amount of research into,
expensive
like what
to
he
it's not
can
that
still
expensive
take like
to
2 weeks
rent
to add
GPUs,
support
and
on
it's like
macros.
okay if I
Which
can
is what
find
would be
a
needed for people to
decent
write
enough data
Rust
set of
related.
like
Right.
Daphne
So,
proofs or something.
meanwhile,
or,
I've been trying to get jobs
I don't know,
to
pick your
work.
language.
But
that might be a fun little thing. Of like, here's an LLM that's like specifically for formal verification stuff.
Yeah,
I imagine people will do that.
I feel like
not a novel idea.
I feel like they're.
I don't know.
My experience with like LLMs writing code right now is it just feels a little stuck. So as soon as you get out of the like
Do we need to,
normal,
like,
it's
dispose
been
of some
trained
of
on a
this
bunch
stuff?
of
Yeah.
We'll need to,
a bunch of code, then you're
consolidate pizzas, I might
you
get
can't write it.
another slice or two, but then if anybody wants to take some home, feel free to do so.
The cons of riding a bike to the meetup.
I can take pizza home.
Okay.
Cool.
I'm
I'm
making a
making
bunch of cheese.
Yeah, I got a bunch of cheese, got a bunch of veggie.
I'll see you,
Anybody else wanna
one of
take
these
pizza
days.
home?
Yeah.
I'm okay.
Thanks again, Charlie.
Yeah, thanks for coming.
Yeah, I'll see you soon. And, everybody else, good to see you.
Yeah, good to see you.
Thank you.
Nice shirt, by the way.
Thank you.
Yeah, very bright. Okay, nobody's taking pizza home? Yeah.
Stuff
Well, you know what,
somewhere.
We got
I'll
vegetarian, we got
take
cheese,
one.
and we got meat.
What do you prefer? What do you prefer?
He's
one of
vegetarian,
these,
so-
one of these.
You guys can swap slices and give everybody a.
Yeah.
Yeah.
Doesn't matter to me.
Well, can you prove that that gives equality?
Yeah.
You
I
can.
mean, like, if there's not at least 3
It's gonna take a
slices,
while.
then, you know.
I can take the cheese.
It's like, no,
It's up to you.
fine.
You guys, you sure? You take it off.
I know.
Good to see you, man.
Thank you. Oh, it's heavy. Anything I can help with, Charlie?
Yeah, I'll carry whatever out of here. I need to carry the pizza to your car, and not have any myself.
I will.
Oh, wait, you didn't know? Oh, fuck, I didn't know. You must have told me about something. I live in Riverside. Here, I can walk to.
Yeah,
45
Riverside.
minute walk.
Nice. That's not so bad.
Yeah, but just carry stuff. and
You
you
just
know
take
what
the
it
first
is.
street bridge and do there. Charlie, I won't be here next month. I'll be in Georgia. But yeah, I don't know where these videos get posted, but it could be really cool to.
It didn't look like it was recording this time, but I'm sorry.
Well, it turned red.
I
No.
turned it on a little late, I'm so sorry.
No, that's fine.
I had to call our AV person because it
Yeah.
wasn't streaming right at 7, but I turned it on like around 7:15.
Oh, okay. Yeah, that'd be fine.
So here in a second, it should cut off, but Eli usually sends a link right after.
Oh,
So
okay.
you should be able to send that tomorrow.
Oh, sick. Cool, thank you.
Yeah, of course.
Cool. Yeah, going to Georgia to visit family, and I go to a hot air balloon. I help with a hot air balloon race of the year, so
Yeah.
that's what we'll be doing. Yeah. Good time. 52nd year.
What do I need help from you? Carry this out?
Do you need a beer?
That one I could probably do.
Okay, yeah, go for it, yeah.
Alright, silence, Charlie.
Alright,
See ya.
What was your name, by the way?
Oh, yes, Pranoy.
Pranoy?
Yeah.
Silas.
Silas? Nice meeting you.
Wait, did you get on the
Zulip?
No, not yet. I got the link, so I'll sign up.
You might need an invite. Do you have anybody else's contact? Are you on the meetup?
Yes.
Yeah, just DM me on the meetup.
Okay. Okay, awesome, thank you.
It's whatever happened, that's what you had to carry it. So if we're gonna throw it away, we should empty it out and put the box somewhere.
Yeah, yeah.
Just throw it as a or pizza.
That's all right. If we're only off by a few slices.